Yeah, good morning.
Good morning, sir.
Yeah. The screen is visible, isn't it? So I'll show you the scheme first. I'll explain the scheme. Is the screen visible? Soham, is there? Anybody?
Yes, sir, visible.
Yes, sir.
Yeah. Yeah. Thank you.
Yes, sir. It is
So
visible.
you have, yeah. So you have these many subjects. That was in the last semester, correct? Now currently in semester 6, you are going to study MST, that is Machining Science and Technology. Then Process Engineering and Tooling, the short form is PET. Then Production Tooling, the short form is PT. Machining Science and Technology, it is MST. Machine Design 2, you know it is MD2. Hmm. Then Production and Operation Management, that is POM. And then you have departmental level. Now here, for Process Engineering and Tooling, you will be having 4 classes in a week. This is for the theory, and the course code is PC602. If you want, you can take the screenshot of this. So the course code is PC602. You'll be having 4 classes in a week. The credits is 4 for theory. Then you have lab, and the course code for the lab is PL602. That is L for lab. And you'll be having 2 hours of practicals per week. And the credit for this is 1. So altogether you will have 5 credits for PET. Now coming to the marking scheme. So we'll be giving 2 tests, that is test 1 and test 2 2020. And it is not best of 2, but it will be average, which you know. Then end semester examination, that is 80 marks. So 80 plus 20, that is 100. Then here you have lab now. So in lab you have term work, that is for the 25 marks, and you have oral for 25 marks. So that is 50. So these particular subjects, that is PET, will consume 150 marks out of your 750 marks. Then you have term work in this semester for 4 subjects, that is MST, then PET, then PT, and MD2. And you have oral for PT and PT, that is production tooling. That is for the 2 subjects only. Then many of you, I think, are deciding upon department level optional subject. So you have to select out of these five. That is, I think mostly many of you are inclined for robotics and rapid prototyping. You have three more subjects, that is reliability engineering, refrigeration and air conditioning, and MPC, that is manufacturing planning and control. Hmm. So just have a look on this scheme for 2 minutes. All right, now we'll go through the syllabus. So it is 502. Sorry, it is semester 6. So it is PEC 602. So this is your syllabus, and this is what is your objectives is. For every subjects, you are supposed to know the objectives. That is, what is the course objectives and what is the course outcomes. And this is what is your syllabus is. So if you want, you can take the screenshot of this objectives and outcomes, because mm, the observation was last time in the oral we asked what is the course objectives and what is the course outcomes during the oral, and few students were not able to tell what is the course objectives and what is the course outcomes. So if you have any doubts in this, you can please ask. Now, course objectives is nothing but to familiarize with the significance of process engineering. So, what is process engineering and how it is related to the manufacturing operations? So, that familiarization. Then, second objective is that you should be able to prepare the machining sequence. That is, I will show you the drawings. Huh? So, you should be able to prepare the sequence, that is right from the receipt of raw material, and then you must be able to estimate the manufacturing time, that is how much the each operation will consume the or will take the time, because finally the depends on the costing depends on the time. isn't it? Because basically all the operation, like say if you talk about CNC lathe, so CNC lathe the costings are right from 250 as minimum as 250 rupees per hour to as high as in case of laser it will be 5,000 or 6,000 rupees per hour. So once you know the time, then you can decide upon the costing. Hmm. Then you should get acquainted with the tolerances. Hmm. What kind of tolerances are observed in design and what kind of tolerances can be obtained in manufacture. So this is what your objective is. At the end of this course, you should be able to do this. So that is what is the success of this course is, and it's really a core subject. Hmm. Then you must also be aware of basics of the processes and operation planning. That is, suppose if you have given an object, hmm, then what should be the raw material shape? That is, what should be the basic shape, and can be how that basic shape can be produced by which process, whether you have to go for casting, whether you have to go for forging, or whether you have to go for powder metallurgy, or you have to simply go for round bar. So in that case the quantity, the first thing is that the quantity matters. What is the quantity? Like suppose if I show you, just have a look on this component. I'll just show you one component, just simple component, very simple component. This is this the name of this component is ball pin. Just have a look on this component. Students are still joining.
So your mic is off.
Rani sir, try reconnecting your microphone into your PC or laptop.
Yes.
Yes, sir. Now you're audible.
Yeah, yeah. No, I kept it on mute because of some disturbances here.
Oh, okay, sir.
Yeah,
Okay.
no. Yeah. Quantity is 10,000 pieces. So now you decide how what will be the manufacturing sequence for this particular component. This type of questions will be asked, in the Viva. First, you have to study the drawing. See, the manufacturing process will vary as per the quantity. Like suppose if the quantity is one, then you will take a round bar. If the quantity is one, or if the quantity is 10, then you will take a round bar and you will machine out of that. Hmm. Slowly, you will come to know how this component can be produced. If the quantity is more, like say 10,000 pieces, then definitely you will go for a round bar. Hmm. Then you will look for the material. Hmm. Whether the material is of forging quality or not, or if anything is mentioned in the drawing. Now here it is mentioned in the drawing clearly that it has to be a forging, isn't it? So obviously you will go for the forging. If the material can be cast, then you will go for the casting. Hmm. And if no machining is required, then probably you will go for the powder metallurgy if the component is small. Hmm. Now, this particular component, if it is produced in 10,000 or 15,000 numbers, then the manufacturing plan for this will be you will be going for the forgings. You will be going for the forgings. Then you will go for SPMs, that is special purpose machines. On special purpose machine, you will do facing from both the sides. Then again on SPM, you will go for centering, that is, you will do the centering from both the sides. Uh, Even though it is not shown, you need centers here, and that centers can be machined off later on. So there are SPMs like facing and centering. Then you will go for CNC lathe. Then on CNC lathe, you will do two setups. In one setups, you will machine from here, and here up to this. And probably suppose if you use a proper tool holder and an insert, that is SVBBN type inserts, where the insert angle is 29 degree, then you will be able to machine this also. So in one setup only you can finish this entire profile. Then on CNC you can set up two way. What you have to do, you have to simply do the facing of this. So that is your turning. Then once the turning is done, then you will go for, now you have to decide whether you will do threading or whether you will do drilling first. So there is a drilling here and there is a threading operations. So if you do threading first and then drilling, then the drill will not get a proper support. isn't it? You will not get a proper support, so drill may slip. So that's why you have to go for drilling first. So the next operation will be drilling, and then later on you have to go for thread threading. Now again, threading you will not do it on lathe. You will do it on a special machine that is called the thread rolling. So once this threading is done, then you have to go for the hardening. Now hardening also you have to do at particular surfaces. You are not supposed to do hardening everywhere, particularly threads. Threads if you harden, then it becomes brittle and it will break. So in process engineering, we are going to learn how to do the selective hardening. Once the hardening is done, then you have to go for the centerless grinding and so on. So this is the roadmap. This is the manufacturing plan for this.
Sir, doubt.
Yes, please.
So you said कि after lathe machine take it for threading, you take it to roll threading, right?
Thread rolling.
Thread
Up,
rolling.
up,
So
thread rolling.
why can't we do the threads in the lathe machine itself? It will save one more machine and one more step to transport that amount of material to other machine.
What happens? No, here the quantity is 10,000 pieces.
Yeah,
And
that's what
then
I'm saying. If there are 10,000 pieces, why can't we? Because if the threaded area is small, why should I have to take the whole batch to the thread rolling machine? Because again, it will include transportation time as well as a bit of cost for using a secondary machine.
that is what I'm telling now. So what happens in CNC lathe if there are two issues now in this case. First, if you do the threading, then the drill will slip. Drill will not get a proper bite. You will not get a proper bite. So on the threads, the drill will slip. So you have to do drilling first and then threading. That is the first issue. Second is on CNC lathe, if you do the threadings, it requires minimum, 6 to 7 passes. It requires minimum 6 to 7 passes and plus idle passes to get the good finish. So altogether there will be at least 8 to 9 passes. So these 8 to 9 passes for this threading length of 14 will take at least 50 to 60 seconds, or say let's talk 1 minute, considering the tool indexing and homing, etc. So minimum 1 minute it is going to take. Whereas suppose if you do this component on thread rolling, this component if you do it on thread rolling, in thread rolling what happens, I'll teach you that process also later on. uh, in thread rolling, in just one rotation of the component the threading is finished. In just one rotation of the components the threading is finished. It is so fast. So that takes 5 seconds, 5 seconds for the machining, and then loading and unloading. So altogether it will be 10 seconds. So it will, thread rolling, the production rate will be almost 6 to 7 times than your CNC lathe.
Okay, sir.
Yeah. So I hope it is clear.
Yeah, yeah, understood.
Yeah. So thank you for asking this. So others also understand. So I'll close this and later on I'll upload this component. Want to join this one. All right. So I was talking about objectives. Now, what is the outcomes? So outcomes will be that you will be able to decide, what will be the machine sequences. Just now I told, that is, you have to do hardening first and then only you have to do grinding, or you have to do drilling first and then only you can go for threading. Then whether to go for the thread rolling or whether to go for CNC or whether to go for SPM, that is facing and centering. Hmm. Then you must be able to analyze the part prints. Part prints. Analyze the part prints. Analyze part prints means you are doing the postmortem of the part prints. Like I'll show this component. Mm, So every dimension you have to study here. Now here, what is this symbol stand for? Three triangles. Now, what is this plus 0.05? What is this spherical is? What is this nine reference is written here? Nine reference is written here. Hmm? Then what this is here? It is written. I will share the good copy. This is gauge plane. This is what is your gauge plane. Then this is again, a taper grinding is mentioned here. Then this is minus zero point zero 0.02, M10 by 1.5. Then ball surface induction hardened to HRC 50 to 56 to a depth of 1 to 1.5 millimeter. So all these things then forging to be heat treated to BHN 200 to 250. So what is this BHN is? Then C40 steel or EN8D. Uh, FCQ. What do you mean by FCQ? So all these you have to understand. I'll show one more drawing. See here now one. This is your transbearing cage. So here again it is written in the note bores 100.099.98 and 75.074.98 must be concentric with the diameter 125 within zero point zero 0.05 TIR. So what is this TIR means? Then here the tolerances were not specified. Tolerances were not specified. How to give the tolerances? That is from 0 to 10. What should be the tolerance? From 10 to 30. What should be the tolerance? From 30 to 100. So this is what is called as the postmortem of the drawing. So you must understand each and everything that is mentioned in the drawing. So this is what is called as analysis part pin, and we have one module that is preliminary part pin analysis. Preliminary part pin analysis. We call the PPAP. Uh, then you need to prepare the outcomes will be you will be able to prepare the tolerance charts and with it balancing. Balancing means tolerances should not be too tight. At the same time, it should not be too close also. Then you will be able to design the fixtures, that is work holding devices. Hmm. And that is what is called the workpiece control. That is, if the work if the job is too delicate, how to hold it, or if the job is cast, if the job is forged, then how to hold it. You understand, no? That is, if the component is like a egg, egg, egg. So how to and do the drilling from the tailstop. So what kind of fixturing will be required to hold a egg which is very delicate, or a thin wall component like a bush having a wall thickness of 1 millimeter? So how to hold it in a check? Because if we are talking about 1 millimeter, so it's like a egg only. Hmm? So if you are having a check for say for ramming, it's going to collapse. So how to hold your work holding devices? Then you have to prepare the process picture. Process picture means it gives an idea. It's kind of a SOP. So it gives an idea for the operator that how the component is located, how it is hold, how it is clamped. Hmm. So it's a pictorial view. What kind of machining, which areas to be machined. So that is what is called the process picture. Then process routings or process sheets. This is very common in the industry. That is, we have to prepare a root card, and then that root card goes along with the bin, and in the bin you have workpieces. So every bin in which the components are lying will have the root cards, right? And then in that root cards, the complete, the root, that is from which machine, from which process is going will be mentioned clearly. So anyone can glance it and he'll come to know the complete history. Then design cams. So this is something interesting. How to design the cams on single spindle automats. Now these cams are not the cams which you have learned in Tom theory of machines. They are automatic with the front and we are going to use on the Automates are nothing but again mass production machines. Single spindle automats means it has only one spindle. Similarly, you have multi-spindle automats. And this is what is your syllabus is. It is divided into altogether six modules. We are going to start with module one, that is process engineering. What is process engineering? What is product engineering? Then I'll just give the bird eye view. Is module 2, it is preliminary part pin analysis, that is just then workpiece control. Workpiece control, I told you that how to control the workpiece so that you get a good geometric control. Good geometric control means workpiece should not deflect, should not distort, while the forces are applied. Then you should get a good dimension. That means whatever dimensions are mentioned in the drawing, should be able to achieve it. So how to do the referencing for that? Then mechanical control, uh, how to locate the components. So that's all comes under the workpiece control. Then you have tolerance design. So how to design the tolerances, how to do the balancing. So that is your main analysis. Then process planning. In process planning, how to classify the operations, what is the basic process operations, that is when to go for casting, when to go for forging, when to go for rolling, when to go for. So it's a multidisciplinary subject. You should have a knowledge of machining science and technology. You should have knowledge of theory of machines. You should knowledge of jigs and fixtures. Unfortunately, the two subjects, that is production tooling and machining science and technology, you are going to learn in this subject. Actually, you should have prior knowledge of MST and production tooling. So your juniors, that is your research team, machining science and production toolings will be taught in the fifth semester. So in the sixth semester, when they come for the process engineering tooling, that time they already have a knowledge of production tooling and MST. But now in this semester, you are learning it simultaneously. Then how to do computer-aided process planning, what is the advantage, what is variant approach, and what is generative approach. Then operation planning. So in operation planning, now you are doing calculation for each and every operations. Even if you are doing facing, so what will be the time, hmm, how to calculate the time required for facing, how to calculate the time required for turning. Not only facing, turning, not only lathe operations, but how to calculate the gear hobbing time, how to calculate the gear shaping time, what will be, what about calculation of the time for the millings, for the drilling, not only this, for the grinding also, that is cylindrical grinding, surface grinding, hmm, centerless grinding, how to calculate the times. And finally, for your hardening also, your surface treatment process also, how to calculate the time, which I am sure that you have not learned, how to calculate the time for hardening. How the hardness varies. Hardness depends on what, how long the current has to be you know circulated, for how much time, what should be the value of the current, and so that how much case depth you are going to get in induction hardening. So all that calculations will be taught in this operation planning, so that you will be able to calculate the total time, and this will be useful for giving the quotation to the customer. And then there are some few aspects of process engineering, like what are the high speed machines, then what is SPM, then what is transfer line, what is and finally cam design. So here you have, so this is, there is a kind of a numericals here, and this is again a totally numerical. So you have 120 marks, totally numerical question. Of course, not 20 marks, but 16 marks, because 4 marks will be for drawing. draw the line out. So will be a numerical on this, then some numerical here, and then some numerical in tolerances. So um, if we talk about um, total mass with the options, it comes say 80 plus 20 plus 20. So that is say 120 statistics that exams will happen offline. So out of 120, around 40 marks will be for the numericals, around 40 marks, and rest will be theory. Operation planning, one questions, then process planning, one question. So that consumes your 40 marks. Then preliminary part pin analysis, that is again a long question, so that is 20 marks. So that goes now 60, and then 20 marks for the cam design, so that is 80. So these are all big questions, cam design 20 marks, operation planning, process planning, that is 20, 20, 40, and then preliminary part pin analysis, that is 20. So that comes around 80 marks, and then 40 marks that will be totally theory, short note, that will be for the process engineering, then tolerance design, and these are the round selected questions. That is 6 questions. Question number one compulsory, and then most of the process engineering, product engineering, tolerance, that is module one. This module one, and then this module two and module three are covered in this, that is process engineering and manufacturing by ARI, and we have plenty of copies in our library. Mm. Then next question is operation planning, process planning. These are all like you should have a practicals. That is your manufacturing processes, whatever you have learned in the second year. You can refer production technology HMT, but practically speaking, you need to refer only one book, process engineering and manufacturing, and the rest of the questions can be answered just by doing the assignments and by solving the question paper. That is whatever is in the book, whatever the notes that I will share. And now coming to the assignments. So here you have lab, and in this mostly it is assignment based. Again, these are the minimum assignments. So what you need to do, at the most we may skip one. So if you want, you can take a screenshot of this. Mm. But from your examination point of view, assignment number two, that is part P analysis, is very important. Then process planning is very important, and design of camps. These three assignments are very crucial and very important. Part P analysis, then process planning, and cam design. Just go through this. So introduction to process engineering, it is straightforward, theory based. Part pit analysis, you should have knowledge hmm, of all the machines and understanding of the drawings. Then process planning and sheet, you should be familiar with all the processes. And then CAM design is totally new for you, and it is not what you have done in theory of machines. Now, depending upon whether it is going to be offline or online, what I am talking this is for the offline, hopefully. So the distribution of the mass for the term work is this, that is design exercise 12 marks, then assignment, then industrial visit if it is offline, and then attendance. Then your practical and oral examination again if it is offline. Then you will be given a task hmm, that is right operation sequence for this component, or do preliminary part analysis, or do CAM design. So that is 15 marks, and then oral will be 10 marks. So like that it is. So I hope it is clear the scheme, then course objectives, then your course outcomes, then what is syllabus, what we are going to learn, huh? And what will be the assignments. I hope everything is clear. So we'll go for our first module, that is process engineering. Hmm. So what is process engineering tooling and what is its scope? So scheme I have explained. Hmm. Then syllabus also I have explained. Hmm. Then applications, that is why to study this process engineering and tooling. So many times now you will receive drawings and you need to give the quotations, or you need to give the time, kitna time mein dega, what will be the cost, what will be the lead time, what will be the manufacturing time, when the project or when the machine will be ready. So this is what you are going to learn in this, and that is what is the scope or the application hmm, of this subject. Hmm. So process engineering is called as the hub. So this PPT itself will serve as a notes, and I'll share some more notes also, which will be helpful. So why it is called as the hub of the organization, or what is its role, or what do you mean by organization, or what is organization chart is. So most of you are familiar what is an organization is, or what is industry is, or what are the different departments in organization, or what is the hierarchy in organization. Just have a look on this. So a typical organization will have um, a marketing department, a sales department. You know the difference between sales and marketing. Like in sale, you already have a market for a particular component, and you don't have to take any efforts for selling. Market is already there. Like for example, you take an example of say toothpaste, so or soaps, mm, or FMCG. mm. So here you already have a market, so you don't have to take much effort for selling. You just have to go on producing. So that is what is called the sales. And in marketing, it is not required. You have to create a market for the product. Mm. Like you can say smart TV. It is not required, but you are creating a market. Mm. You are educating the customers that how the smart TV is important. What are its benefits? Mm. So you are making customer to purchase smart TV even though he can live without smart TV. It's like selling a refrigerator on a North Pole or going to Himalaya and selling a refrigerator or selling a air conditioner for there. So that is what is your marketing. Hmm. It is not required, but uh, you are you are telling them, that how it is going to be useful. So you'll have sales or marketing department. Then once the marketing department gets the order, then that is passed to the design. So the design department will do the designing of the product. uh, and there in design department you will have a team of designers, a team of product engineers, draftsmen. You will have manual drawings. You have computer drawing. Now nobody does manual drawing, so it is all computerized only with the help of various modeling softwares. And that is what is your product engineering is. Then once the design is ready, then you have to give the product engineer has to give the drawings. He has to release the engineering drawings. That is what is called as the engineering release, hmm, to the purchase or to the process engineer. And then process engineer, he will procure the material. Then production engineer, or process engineer, he will make the plan how to do the manufacturing, whether any tools are required, what will be the methods. mm. He will interact with the tool design, he will interact with the tool room, and he will interact with the production. So most of the companies, big companies, the process engineering department is a separate department. And let me tell you that process engineering, you don't mix up with the production. So production is different and process engineering different. So process engineering is very very beautiful department where you get to learn everything. And in process engineering department, you should know each and everything, and you need not be, master of all, but you should have knowledge of everything. That is, you should be able to understand, you must know what are the modeling software. You should know how the induction hardening process is carried out. You should know what is CNC machines. You did not know what is, programming in detail. That is not required. But you should know the functioning of the CNC lathe, functioning of the CNC milling machines. You may not be able to design the tool. Now here tool means not only cutting tool, but tool means here your holding devices, that is fixtures, then your jigs, then your cutting tools. You should be able to understand that this particular component will need G, this particular component will need a two jaw chuck, this particular component will need a three jaw chuck, will need a four jaw hard chuck. So this kind of decisions you should be able to take as a process engineer, and these kind of decisions are taken in process engineering department. So once you decide, yes, now this is going to require a two jaw chuck. I don't know whether you have heard of two jaw chuck. So then you discuss with the tool design department, or this particular component is going to need a form tool. Then you discuss with the tool design department, this is a component is, now I want a form tool for this. So the tool design department will design the tool for the component. They will design a fixture, or they will design a two jaw chuck for that particular component. Hmm. Process engineering department also called as the methods department, because here you are deciding, you are taking decisions, what should be the basic process, whether you are going to cast, whether you are going to forge, whether you are going to pack. You are giving a complete manufacturing plan, right from basic raw material to the finished. It also includes all the logistics also, how you are going to deliver. Not only that, how you are going to deliver, but how you are going to pack it. In packing, whether you are going to pack, whether you are going to deliver in a bins or in a long 20 feet, 20 cube high containers or 40 cube high containers, whether you are going to mount it on just a pallet, or you are going to fix up in a wooden box, and then that wooden box will be loaded in container, and then that container will be dispatched, whether by road or by air or by sea, what ports, which ports, how to connect. All these logistics also comes under methods, because we need to estimate that cost also, isn't it? What will be the container cost of 20 feet high or 40 feet high? What will be the cost on the wooden pallets? And what will be the cost on the wooden boxes? What will be the cost of dispatching? If you deliver by air, what will be the cost? So all that costing you have to consider, and then only you can quote to the customer. So this is also very important. So that itself is a project, the delivery of the components. I don't know whether you are familiar with Lavaka Ganpati. So Lavaka Ganpati from Lalmot to the Chopati, it takes 24 hours. That I will say in our technical language, I'll take it is delivery time. So the entire route has been well planned. Entire route, the engineers working on that entire route. How to load, how to unload that statue, which kind of trolleys to use, on which roads, which route it is going to follow. mm, what are the, are there any bridges, are there any flyovers below which this is going to travel. What is the height of that? Mm, where to deflate the tire wheels, where to how to inflate. And sometimes if the bridge height is more, then you need to deflate. So deflate the tires. So in that case, how it will be, moved. So all this has been planned, manually, has been planned beforehand. So all this is done in method department. So once the tool design is ready, then you have to interact with the tool room for manufacturing of the tools. And once the tools are ready, once the methods are set, then you have to hand over, then you have to have a pilot run, of course. And once the pilot run is successful, then you have to go to the production. Then after production, your job is not over, because you have to also have the procedures set for the inspection, how you are going to inspect it, whether sampling or whether 100% inspection, what kind of gauges you are going to use it, that all you have to design, you, that is process engineer. Whether you are going for, electric or electronic gauges, or you are going for pneumatic gauges, go type gauges, no go type gauges, all these, everything you have to plan, everything you have to consider what kind of equipments. So you need to order whether we have this equipment, whether we have these gauges, and then this has to be considered in the costing, and accordingly you have to quote it. So that's why it is, called as the hub of an organization. And this is what is your role of process engineer is, which is very, crucial, which is very crucial. If anything goes wrong, your, you know, delivery time or your manufacturing may fail. Because sometimes even the FMEA, that is failure mode effect analysis, that also has to be done by process engineer. That is failure mode effect analysis means um, how whether my process will fail or not. What are the chances that my process is going to fail, or what are the chances that design is going to fail? So that is what is called the FMEA design or FMEA process. So that also the process engineer has to carry out. He has to do it. So it is very highly technical, and process engineer, it's a multidisciplinary work, and you enjoy a lot. Yeah. The main thing is that the question which is asked in question paper is why the process engineer is, or why the process engineering department is called as the hub of the organization. Then coming to the product engineering. Hmm. So the module one comprises of two things. One is your product engineering and another is your process engineering. So product engineering means product design. So you have to remember three things here in product design, that is DFM, DFA, DTC, and again very important from examination point of view because short notes, 5 marks. What is DFM? What is DFA? And what is DTC? So DFM stands for design for manufacturing. That is whatever you design should be manufacturable. Then DFA stands for design for assembly. That is whatever you design, uh, there should be ease of assembly. And then DTC stands for design to cost. This is the most important. That is, it should be cost effective. It should be cost effective. That is what is called the design to cost. And how to do this, design for maximize. What are the parameters to be considered when you are designing? Uh, that is what we'll see in our subsequent. So now, if you have any doubt, you can please ask. Okay, then we'll stop here. Thank you so much.
Thank you, sir.
Yeah.